Hey everybody, we have our little quiz over exponents coming up here on Monday of next week. So there is some review materials in Schoology right now. There is a PDF with tons of practice and a key attached with it as well that you can do. And there's also an optional edge elastic practice. Plenty of practice for you guys to do. I'm also providing this video. I would recommend you kind of pause as I go through each slide. Try to do these problems on your own, and then play the video and watch my explanations and check your answers. So here we go. Here is the first slide, the first question here. 3 to the 7th times 3 to the 6th times 3. Now that 3 is really the same as 3 to the first power, so that's how you think of that. And when you multiply, you keep the base, 3, and you add the powers. 7 plus 6 plus 1 gives you 14. So 3 to the 14th power would be your answer for that one. For the next one, you have x's and y's to deal with here. So I want you to think of it as your x's are a problem to deal with, and then your y's are a separate problem to deal with. Okay, so let's look at our x's first. So if we do that, x squared times x to the first is x to the third, and y to the third times y to the fourth is y to the seventh. 3 plus 4 is 7, so that would be your answer for that one. And the last one, m to the third times m to the 10th, keep the base, add the powers, so m to the 13th. Okay, here is slide 2. Again, you may want to pause as we go from slide to slide and see if you can do these problems independently before you watch the video. So here we go with the answers. The first one, these are division questions now. So the property for division says keep the base, 4, and subtract the powers. 11 minus 8 is 3, so that would be the answer for that one. The second one to the right of that question, it looks like we have to do some multiplication up top here with this. So we have to deal with this first, and then we have to divide it by 6 to the third power. So if we do 6 to the 7th times 6 to the 8th, we get 6 to the 15th, and it's divided by 6 to the third. Again, keep the base, subtract the powers. So we do 15 minus 3, not divided, but keep the base, subtract the powers. So it would be 6 to the 12th power. Last one on this slide here. We have x's to deal with, and we have y's to deal with. We're going to deal with them separately. So x to the 5th over x to the 3rd is x to the 2nd, and x to the 9th over x to the 8th is y to the 9th over y to the 8th is y to the 1st power. 9 minus 8 is 1. So we could say x squared y to the 1st, or just x squared y, because y is the same as y to the 1st power. Here we have some power raised to a power questions. Now remember, when we have a power raised to a power, we multiply the powers. So x to the 3rd raised to the 6th power would be x to the 18th power. If you can imagine x to the 3rd raised to the 6th power, that would be like x to the 3rd written out 6 times. How many x's would there be altogether? There would be 18 of them, hence the answer x to the 18th power. In the next question, we have two terms. We have 3 to the 4th and we have 4 to the 6th, and they're both raised to the 3rd power. We're going to apply that 3rd power to this and to this separately. So 3 to the 4th raised to the 3rd is 3 to the 12th. 4 to the 6th raised to the 3rd is 4 to the 6 times 3, which is 18. So that would be your answer there. Last question is similar. We have a m to the 8th that we're raising to the 4th power, and an n to the 11th that we're raising to the 4th power. These are not like terms. We cannot combine them, so we'll handle them separately. M to the 8th raised to the 4th is m to the 32nd, and n to the 11th raised to the 4th is n to the 44th. Multiplying the powers there. Here we have some negative powers to deal with. You may recall the property. When we have a negative power, we move that exponent to the other side of the fraction, and that turns the power positive, which is what we want. We can't have negative powers in our answer. So imagine this right here over 1 right now, and we're going to take this on top, and because it's a negative 4 for the power, we're going to bump it to the bottom, and we're going to rewrite this as 1 over 5 to the positive 4th power. So in other words, 5 to the negative 4th power equals 1 over 5 to the positive 4th power. Let's look at the next one. We have division here. You may notice there are more g's on the bottom than there are up top. That's a hint that you're going to have to deal with a negative exponent. So when we divide, we keep the base and subtract the powers. That's g to the negative second power, but we can't leave it like that. Remember, we have to rewrite it as 1 over g to the positive second power, and that would be your best answer. Another way of thinking about it is there's 2 more g's down here than there are up here, hence g to the second in the denominator of your answer. All right, let's look at the last one. So x's to deal with, y's to deal with. So x to the fifth over x to the second, that's x to the third. And then y to the third over y to the fifth, 3 minus 5 is negative 2, so y to the negative second. So this is where some kids will get tripped up. So I want you to think of these as 2 separate terms. You have x to the third, it's a positive power, and you have a y to the negative second, that's a negative power. The positive powers stay put, and only the negative powers go to the other side. So when we rewrite this, the x to the third stays up top, and on the bottom would be y to the positive second. The positives stay put, the negatives go to the other side and become positive. Let's look at some 0 power problems. 3 to the 0 power, you may remember from our lesson last time that anything to the 0 power is 1. So 3 to the 0 power is 1. That's it. Oh man, this next one, we have all of this stuff here. This is a ton of stuff in the parentheses. It's all raised to the 0 power though. So that means that even though the base is complex, your answer is just going to be 1. And lastly, we have 3 to the 5th over 3 to the 5th. This was the most common question missed on the quick check. This will be 3 to the 0. 5 minus 5 is 0. What is 3 to the 0? Well, we already answered that question up here. 3 to the 0 is 1. You can think of it also like this. Anything divided by itself will equal 1. That's the case for anything mathematically. Whenever you take something and divide it by itself, it equals 1. Lastly, let's compare some exponents that start out with unlike bases, but we can make them into like bases. Remember, we always take the larger one, in this case 4 for the first question, and we need to make that 4 into a 2. Luckily, we can rewrite 4 as 2 to the second power. So we can rewrite 4 to the 6th as 2 squared raised to the 6th. And this 2 to the 15th doesn't need to change at all. It's already at base 2. What is 2 squared raised to the 6th? That would be 2 to the 12th. So what is bigger? Which one's bigger? 2 to the 12th or 2 to the 15th? Which one's larger? The one with the larger power. So 2 to the 15th is larger. Let's look at the next one. We have to make this 27 into a base 3 to match up with this. 3 to what power equals 27? 3 to the third power equals 27. So we could rewrite this as 3 to the third power raised to the 8th power. And this 3 to the 28th power stays the same. What is 3 to the third raised to the 8th? It's 3 to the 24th power. So again, which one's larger? 3 to the 28th is larger than 3 to the 24th. All right, that is it for our review examples. Hopefully that helped watching that video. Like I said in the beginning, go ahead and try some practice problems on the PDF posted in Schoology. The key is also on that document, and there's also an Edulastic practice. Please schedule a conference if you need anything leading up to the quiz. Hope you guys are well. Thanks for watching, and keep it 100.